In this video, I'm going to talk about again ISIS, but about the topology and database of the ISIS specifically, and also some another features of the ISIS. As you remember in the previous video, we configured this scenario. We learned how we can configure ISIS, how we can configure the net address on each router, and also how we can configure the IS type in the, for example, routers for level 1, level 2 only, and also level 1, 2. Also, we learn about the configuration of the ISIS on the interfaces. For example, we learned that we can use IP router ISIS for enabling ISIS on one interface, and also if needed, we can configure the circuit type of the one interface or one circuit to level 1 or level 2 only, and also level 1, 2. Finally, we learn how we can configure one interface as the passive interface. Also, we use some show command for verification of the ISIS function. For example, show CLNS neighbors, or show ISIS neighbors. In this video, I'm going to talk about the topology and also database. What is the topology? You know it. Look at here. In this scenario, for example, in area 49.0.0.0.1, the first thing after configuration of the ISIS that is happen is creating the link states in all routers. You know that R1 should create its link state, and also R2 should create its link state, and finally R3 inside of their area. Okay, and after that they should advertise their link state to other routers inside of area. After exchanging the link states in this area, every router, each router can draw the topology of this area. Okay, and after creating the topology, they can use the addresses on this topology, okay, to completing their database. The addresses on the topology can create the database. Let me to show you first the topology in this scenario for level 1 topology, level 2 topology. Okay, you know that we have two types of topology. The first type is the level 1 topology that is creating inside of one area. Okay, or also we have another type of topology. We call it level 2 topology, and you know that level 2 topology is using for establishing communication between the different areas. Let me to show you the topology first. After topology, we can talk about the database in ISIS. How we can verify the topology in every router? It's so easy. Look at here. You know that in R1, we have only one type of topology, level 1 topology. This means that R1 doesn't know anything about the, for example, topology of the area 49.0.0.2 or area 49.0.0.3. You know that R1 only knows the topology of this area 49.0.0.0.1 because this is a level 1 router, and level 1 router only has level 1 topology. Also R2 such as R1. But R3 has level 1 database, that is the level 1 topology, that is the topology of the area 49.0.0.0.1, and also level 2 topology. Don't forget that a level 1, 2 router has only the level 1 topology of its area, not another area. Look at here. For example, here we have another level 1 topology between the R6, R5, and R7. And R3 doesn't have that level 1 topology. R3 only has the level 1 topology of itself area, okay? And after that, R3 has also the level 2 topology. Let me to show you the topology of R1, R2, R3, R4, R5, R6, and R7. First, the first question is what is the command to verifying, to checking the topology. The command is so easy. You should use show ISIS then topology. If you want to see only the level 1 topology, you can use show ISIS topology L1. Or if you want to see only level 2 topology, you can use L2. The both of commands show ISIS topology L1 and show ISIS topology level 1 has same result. Okay, L1 means level 1, L2 means level 2. You can use one of them in one show command. But in R1 we have only one topology, level 1 topology. Because of that, it doesn't need to configure to use the L1 or, for example, level 1, because we have only one type of topology, level 1. You can use here show ISIS topology, and also in R2. But in R3, if you use show ISIS topology, you will see two types of topology. Maybe you want to see only one of them, then you can use the show ISIS topology L1 to filter the result. Okay, don't forget that in the level 1 routers we have only one topology, L1. In the L1 2 routers we have two topology level 1 and level 2, and in the level 1 2 router you can use the filters show ISIS topology L1 or L2. Let me to start with the verification of topology. For example, in R1, this is the R1 CLI, I'm using this command en then show ISIS topology. This is the topology of the router 1. You know that this is the level 1 topology. Look at here, show ISIS topology L1 can give us again the same result, but L2, look at here, L2, it doesn't have any result. Why? Because we don't have level 2 topology. Very good. Let me to talk about the show ISIS topology level 1. Okay, as you can see, this is the topology of R1. Don't forget, this topology is the level 1 topology from the view of the R1. You know that R2 and R3 should send their LSP or link state to the, for example, R1. In R1, now we have a view about the topology of this area. Look at here. This is the view of R1 about the routers, about the ISS in this area. You know that R1 knows that itself. This, as you can see, the R1 line is empty because this is the view of the R1 for this area. Because of that, R1 is not any, has not any value, because this is R1 itself. But R1 knows that it connected to the R3 with the metric of 10. You know that in ISIS by default every interface has the metric of 10. Because of that, as you can see, the metric between R1 to R3 is 10 because we have only one link. And after that, the next stop is R3. Means if I want to receive to the R3, I have the metric of 10 and the next stop is R3. This means that I connected to R3 from the view of the R1. And after that, over my serial 10 interface. Don't forget that this is my interface, serial 10. This means that I can reach to the R3, okay, directly with the metric of 10 over serial 10 interface, and the SNPA means the layer 2 address is the HDLC. You know that in HDLC we don't have address. Because of that, here we can see the HDLC. In the future videos, I will show you when we are using the Ethernet link. Here we can see the other addresses. Let me to talk about this in the future videos. But for now, as you know, R1 knows that it connected to the R3, okay, with the metric of 10 over the serial 10. And also R1 knows that it can reach to the R2 with the metric of 20. Okay, look at here, we have two link, metric 20 with the next stop of R3 and over the interface of serial 10 with the SMPA of the HDLC. This means that according to the R1 view, R1 knows that it connects to the, for example, R3 over the serial 10 with the metric of 10, for example, okay, to the router 3, and after that it can reach to the router 2 again with the serial 10 with metric of 20 and with the next stop of R3. This is the view of the R1. Look at here, R1 knows that it connects to R3. Why? Because the next stop of R3 is again R3.